Now we're going to look at some more numerical summarization measures that can be used to understand the data even better. And one such measure is quartiles. Now quartiles, what it does is it takes the data, ordered data, okay, smallest to the largest, and then breaks them into 4 quarters. Okay. Now if you break them into 2 halves, okay, top half and the bottom half, the midpoint is the median, right? And that is 2 quarters down from the top. So that's the number that occupies that position is called the second quartile, Q sub 2. Now you take the top half and divide that into 2 halves. So you have the first quarter and the second quarter. So the number that occupies right at this, the number right at the center of the top half, so that will be 1 quarter of the list down from the top. So that number is called first quartile, Q sub 1. And similarly, when you go down from the midpoint quarter down, so in other words, in the bottom half, you divide the bottom half into 2 equal halves, and the midpoint there, that's Q sub 3, because that's 3/4 of the way down, okay, 3/4 of the way down from the top. So that's called third quartile, Q sub 3. So top 25%, then the next 25%, next 25%, next 25%. Now once you compute this, there's one other measure that we can compute, which is Q sub 3 minus Q sub 1, and that is called interquartile range. So that's the mid 50%. So if you take the range, which is the maximum value minus the minimum value, that is the entire width of the data set. Now the interquartile range, which is Q sub 3 minus Q sub 1, is the mid 50%, the range for the mid 50%. Okay, so that is IQR, interquartile range. Now when you take these 5 numbers, so you have the minimum value, the maximum value, and the midpoint, the median, and then the two Q sub 1 and Q sub 3. So that gives us 5 points. And if we plot these 5 points in this fashion, we call this a box plot. And that's because we put a box around Q sub 1 and Q sub 3. So that's the mid 50%. The height of the box is immaterial. And sometimes the box plots are given in a vertical fashion too. Okay, here it is described in a horizontal fashion. Oftentimes box plots are drawn in a vertical way. Okay, so now you draw a box between Q sub 1 and Q sub 3, that's the interquartile range, and then draw a line for the median. Median is Q sub 2. And then from the Q sub 3 end, you draw a line, and this line is often referred to as viscous, to the maximum value, and from Q sub 1 down to the minimum value. Now, if you have a perfectly symmetric distribution, then the two whiskers will be of the same length, and the Q sub 2 line will be right at the middle. But depending upon the length of the whiskers and where the Q sub 2 line actually occurs, we can tell from the box plot whether there is a skew in the data distribution, and also how tightly knit the values are around the center value, or how widespread the values are spread out by looking at the box plot. So this is called the 5 number summary. The minimum and the maximum, median in between, and then between the two, the top values, the first quartile, and here between median and the largest is the third quartile. Here is how the box plot will look like if you have a perfectly symmetric distribution. Now what if you don't have symmetric distribution? What would the box plot look like? So here if it is left skewed, then you'd see the left whisker would be long and the right side whisker would be small. Okay, and if it was drawn vertically, the top whisker will be long and the bottom whisker would be small, and the median is going to be shifted towards the right. Now this is perfectly symmetric, is right at the middle, and the two whiskers are of the same length. Now here the right hand side whisker is longer and therefore the skew is to the right. And also notice that the median is closer to this side, the left side. Okay, now let's go ahead and get all of this done in Excel. Now we come back to the same data with calories and carbohydrates and sugar of a sample of 7 selected breakfast cereals. Okay. Now we're going to do the quartiles first, and Excel has function for this. We're not going to calculate it by ourselves. We'll just simply use the Excel function. And here you see, as before, there is a quartile legacy function that given only for backward compatibility, Excel 2007 and prior. Now for the current version, there are two functions here, quartile.inc and quartile.exe. That's because the original quartile function that Excel developed had a logical error in it. A lot of people were criticizing when Excel wouldn't admit to the error. So what they did was that they did two functions. One, what Excel had originally, the original Excel function, which is like the legacy function, okay, modified for 2010 and 13 with an INC, and that has the logical bug that Excel wouldn't admit to. So don't use the INC function. The EXE function gives you the quartiles more accurately. So you must always use the .exe function. Whenever a function offers you the option of either .inc or .exe, always use .exe, and that is more logically consistent and gives you more accurate results. So that and the data and the quartiles work like 1, 2, and 3. So you have to provide the number. Which quartile do you want? If you use 1, that will be the first quartile. If you use 2, that will be the second quartile, which is the same as median. And if you use the number 3, that will give you the third quartile. So there, 2 gives you median. 3 gives us the third quartile. Now, of course, we can copy this across, and you'll have the quartiles for all of them. Now, interquartile range is Q sub 3 minus Q sub 1. That gives you the range for the mid 50% of the values. Okay. Now let's set up the 5-number summary. So we have the min at the first value. Okay. Q sub 1, we already have that here. If we copy 2 cells down, we'll get Q sub 2 and 3. And then the maximum is that. So this gives us the 5-number summary. Of course, the 5-number summary is very useful, or it gives you more insights about the data when we plot it as a box plot rather than just simply looking at the numbers. Now, Excel does not give you a command to prepare the box plot. You have to go through lots of little steps to create a box plot in Excel. So we won't use Excel for box plot. What we're going to do is we're going to use the StatCrunch module that comes with my StatLab. So we'll go to my StatLab and use StatCrunch to create the box plots, and then we will copy those box plots and paste it down here. Okay, now we're going to use StatCrunch to prepare the box plots. So log into your My StatLab account and look for StatCrunch. Click StatCrunch, and when StatCrunch opens up, click Datasets from your textbook. Okay, now this is chapter 3 and cereals. So now we have the data. So all we have to do is to click graph and look for box plot, and then select each variable one by one, and you compute, and you have the box plot here. Now to copy paste, you right click in the image, you copy the image, okay, and then go to Excel, okay, And then here again, right click, select paste special, and you insert bitmap. So once you click that bitmap, click OK, and the box plot will appear. Okay. And then you need to size it properly. So here, see, the box plot is vertical. Now you need to repeat this for the other two columns and get the box plot from StatCrunch. So now we have all the 3 box plots, and you can see from examining this, you see there is a skewed to the top part is the larger values, so there is a skew to the right. And you see the median is shifted to the lower side, and the same is the case here. And also notice that the interquartile range is really large here. The middle 50% has a much larger width than the outside 50%. So the mid part has a lot of variability in terms of this is for carbohydrates. The same is the case for calories as well as for sugar. And of the 3, sugar seems to be the one. Well, even here, if you see, there is no line at all, and that's because the median and the first quarter are one and the same thing, 4 grams. So as you can see here, Q sub 1 and Q sub 2 are the same number, and that's why you don't see a line there.